We're solving problem 18 from the 2022 F equals MA exam B. A uniform rod of length L and mass M is placed with its end resting on two identical springs of spring constant K as shown. The rod is initially in equilibrium. If the rod is uniformly displaced downward and released from rest, what is the frequency F of its oscillations? So for this problem, since 18 and 19 are connected, we only need a set amount of information, and then we can use that information to find the answer for the next problem. We want to find the frequency of its oscillations. So when it's being pushed down, it goes back up because these two are springs with spring constant K. The restoring force needed to push it back up is, well, we can write F is equal to negative 2kx. We can then write out Newton's second law, which relates mass and acceleration in this case, because we want to utilize the mass of the rod. So we just write out Newton's second law, and the acceleration is equal to negative 2k and x. Therefore, we can write that this deviation of x, the acceleration, is equal to negative 2k over m times x. Now notice how this form, acceleration, correlates to the form of simple harmonic motion, where we have a formula, or essentially you just use some of the formulas in physics to find that omega, the totally different equation by the way, but you realize that these are essentially the same thing. So you can apply that and then plug it into the original equation to get your answer. So we know that omega is 2k over m, just a general statement in dealing with springs. So what we desire for the frequency of the oscillations in this case will be omega over 2 pi, which you factor it out, 1 over 2 pi times square root of 2k over m. And this leaves you with the frequency of your oscillations, or your answer for this problem.